Hi everyone. This is an example of what we call a solution stoichiometry problem. We're going to follow the same steps as before, however, we have extra possibilities, extra options to deal with. Here we go. Determine the volume of 0.500 mole per liter phosphoric acid required to neutralize 50.0 milliliters of 0.750 mole per liter lithium hydroxide. As always, we're on the lookout for keywords. Here, it's neutralize. Doesn't especially help us in this situation. Lots of solution stoichiometry problems are now going to have 2 or 3 numbers in them. So this strategy of reading the question, leaving out the numbers, and focusing on the keywords might become more helpful than ever before. Determine the volume of phosphoric acid required to neutralize lithium hydroxide. When we leave that out, that maybe helps focus our attention that we're going to have a reaction between phosphoric acid and lithium hydroxide. Phosphoric acid, we can look it up in the data booklet. It's H3PO4, reacting with lithium hydroxide. Lithium 1 plus, hydroxide 1 minus. Neutralization, this happens to be a double replacement reaction. The hydrogen and the lithium exchange spots. Lithium is 1 plus and phosphate 3 minus, Li3PO4. Hydrogen 1 plus, hydroxide 1 minus. We need to balance this reaction. And we have 3 hydrogens on either side, 1 phosphate on either side, 3 lithiums on either side, and 3 hydroxides. We have a balanced chemical reaction. Now we need to move on to our interpretation. Interpret the quote. Determine the volume of 0.500 mole per liter phosphoric acid. This is the first time we've seen this style of question, and there is definitely almost a standard way of expressing things, and it's volume of concentration chemical. We're going to see that not every time, but so often it's going to become second nature. Volume of concentration chemical. Volume, the actual word volume of concentration. That mole per liter is the concentration. Those are the units that give us a signal. That's the concentration. Volume of concentration chemical. All those go together. Volume, concentration, chemical. Look at the other one. We actually have the volume. Volume of concentration chemical. That's going to help with our interpretation. Determine the volume of that concentration, that chemical. So it's saying we're looking for the volume of the phosphoric acid. Determine the volume of the phosphoric acid, and it has this concentration. 0.500 moles per liter. We're not used to that. However, we're going to get used to it pretty fast. Wherever the question mark is, that's the R. That does not change. Extra interpretation. We have 50 milliliters of 0.750 mole per liter lithium hydroxide, volume of concentration chemical, all linked together. Goes with the lithium hydroxide. Here it is. We have this volume, 50.0 milliliters. The concentration, 0.750 moles per liter. We have all of that worked out. Now, we can get to actually doing the work. Lots of work, figuring out the reaction itself, extra interpretation, more numbers to manage, but we're set up, and this is the G. Wherever the question mark is the R, the other set, the G. Let's move on. Find moles. Did we get told the moles? No. Do we have a mass that we can do mass over molar mass? No. All we have are V's and C's. So we're doing C times V. Just like how the mass and the molar mass belong to the same chemical, this C and V belong to the same chemical. Here we don't know the volume. It's the unknown. It's what we're solving for. So we have to do this C times this V first. C times V. The concentration is 0.750 moles per liter. The volume is 50 milliliters. Big reminder, if we're using C times V, or all these volumes over here must be in liters. We need to take that 50 and divide it by 1,000. That's 0.0500 liters. Find the moles using this new formula. Then multiply by R over G. R over G the same as ever, R over G. R1, G3 times 1 over 3. All of that, our initial work and the R over G, we said it before, it's the red N. Red N. Look at what we have now. We're looking for the volume. Find moles, find mass, find concentration, find volume. It's the red N divided by C. All of this represents the red N, so what are we going to do? Divide by concentration. We're going to divide by the concentration, 0.500 moles per liter. Let's divide by 0.500 moles per liter. Now we're set up to get to our calculators and get to button pushing. 0.75 times 0.05 times 1 on 3 divided by, big heads up, that's a divide right there because we're dividing by the concentration. It's so easy to accidentally multiply one more time. Divide by 0.500. This equals 0.025. That's the number sitting on my calculator screen. It's the raw answer. Let me go back and think about the significant digits. 3 sig digs, 3 sig digs, 3. All these values have 3 significant digits, so I have the unusual step of having to add a 0 myself to make it 3 significant digits, and we found the volume. If we follow the algebra of the units, it does give us the volume in liters, or we can remember that all these volumes anywhere here in our steps are liters. This is 0.0250 liters. When we're working with solution stoichiometry style problems, we need to be conscious on the interpretation. It's almost a standard thing. It's not going to happen all the time. Volume of concentration chemical. That's going to help us. Get those labels in the traditional way. Wherever the question mark is, that's the R. Whatever numbers we're going to use to find moles is the G. Make sure that we're converting into liters all of the time. Questions are almost always going to give us the volume in liters. We need to convert it. Divide by 1,000. R over G the same as ever. If we're solving for volume, our last step is to divide by concentration. So right there, we have a division. So easy to accidentally multiply. Heads up on that. Don't forget about your significant digits. Watch those units, and I hope that helps.